Hello everyone, in this video I'll be explaining about simplifying context-free grammars. The two algorithms used to simplify context-free grammar are to find and remove unproductive variables using remove unproductive algorithm, and for this algorithm the input is grammar, that is CFG grammar, and then after that, after applying remove unproductive, the next step to be applied is remove unreachable, and for this also grammar will be CFG. So normally what we do is to identify the useless symbols in the context free grammar, which is actually necessary for that part of context free grammar. Such variables you're going to remove using remove unproductive, and after applying whatever the result you're getting from the remove unproductive will be, or what I can tell is from the remove unproductive you will obtain some context free grammar that will be fed to the next step, that is remove unreachable. So that is we can tell that after this is the first step, and this will be the second step to be applied to find useless symbols in the grammar. Next I will explain how to remove unproductive variables. For that the algorithm would be this. First of all, give a input context free grammar, and that you name it as d dash equal to g. So whatever grammar you have applied, you have taken as input will be initialized as g dash. So let me consider some examples related to this. So first of all, S gives A, B, S gives A, B, and then A gives A, B gives B, A gives A, B gives B. Next, this can give you C, this can give you C, C gives, let's assume C gives C, whereas this is a non-terminal and this will be a terminal. Okay, so whenever this kind of a grammar is given, this will be initially G, and that itself is your G dash. That's what G dash equal to G here in the first step. Then mark every non-terminal symbol in G dash as unproductive. Mark every non-terminal symbols in G dash is unproductive. Let's identify the unproductive non-terminal and terminal. So non-terminal here are the symbols that are present on the LHS of the rule. So there are 4 rules in this grammar. This is a grammar. So 4 rules. What are the 4 rules? 1, 2, 3 and 4. And the non-terminals present on the LHS of the rule. So that's why non-terminal are S, A, B and C. S, A, B and C. Then you have to mark these symbols as productive also. These symbols as unproductive. And which are productive symbols? Projective symbols are terminal initials. Terminals. How to identify the terminal symbols? So productive symbols are terminals from the grammar. So how to identify the terminals from the grammar? You got to know what are non-terminals. Then to identify the terminals, you have to go to RHS of the each rule. This is the rule. This is a rule. RHS of the each rule. So this is RHS for this rule. This is RHS for this rule. And in that, leave the non-terminal symbols and epsilon. Remaining whatever you are getting from the RHS are productive or terminals, and those symbols are productive symbols in our case. So to identify the productive symbols, you have to identify the terminal symbols. So now the terminal symbols, let me write here, are first case A and B are your non-terminals. So here we did not get any terminal symbols. And what about this? Here also non-terminal. C is also non-terminal. So we did not, in the first rule did not give us any terminal. Second rule is giving A, okay, which is not epsilon and which is not non-terminal. So we can write A, and remember, don't repeat the terminal symbols here. Next, go to the next rule, and I have obtained the terminal symbols B, and I have one more here. In this case, I will remove the non-terminal. I have C. So A, B, C are what? The productive symbols. Now, what's the next case? This is the third step. Till third step we have seen. Next step is for fourth step. For each rule, X gives alpha in R. R is the rules of the grammar. In R, what you have to do? You have to check the alpha. What is alpha? They are saying alpha, saying there it's the RHS of the rule. RHS of every rule you have to check, and check whether each symbols of the RHS are productive. Suppose if the each symbols of the RHS are productive, then you can tell that this is productive. See, remember, it is S gives AB or C. So we can write this as S gives AB and S gives C. S gives AB and S gives C. So if suppose if this entire thing becomes productive, then you can say that this S is productive. If suppose this becomes either this or this, anyone says that RHS is productive, then you can say that S is productive. So let's look at this one by one. Okay. Now, until one entire pass has been made without any new symbol being marked, check the rule X gives alpha and check the RHS of the rule and decide whether X is productive or not. So first we have S gives AB or C. So both AB and C are in the unproductive symbols. That's why we cannot tell right now S as productive. We cannot tell right now S as productive. So that's why what I will do is I'll go to the next one. A gives C. A gives C. So in this case, RHS is A. A is in the productive symbol list. A is in the productive symbol list. That's why I can tell A as productive. Now I will add A into the productive symbol set. A into the productive symbol set. So here what happens? A is removed from the unproductive list because now initially non-terminals are unproductive. So remove from here and use for this union A. ABC union A. Next B. So here B is productive. So this in this rule RHS is productive. So we can say that B is productive. Union B. Union B. So next I can say that I cannot say C as productive because here in the RHS we have the terminal C. C is productive but not C. So yet to decide C is this is productive or not. So that's why let us go to the rule which we have not verified. So A and this we have already verified. Coming to this we have gone through, but we did not get the correct answer for this. So now what happens, since A and B both has become productive, we can say that S is productive. We can say that S is productive. Now still, so this is done, only one rule is remaining. That means we did not get any other rule supporting C as productive. So that's why what we can do is we have to remove I can tell we can decide that C as unproductive symbols, because productive symbols contains right now A, B, C, A, B and S symbols. So wherever it is containing C, because in the unproductive list we have only C remaining, we can tell that C is unproductive. C is unproductive. That's why remove that particular symbol from the grammar, from the wherever it is used, whether it is LHS or RHS, everywhere you have to remove. So finally we get G dash as S gives AB, S gives AB from this, then A gives A gives A, I'll write here B gives B. We can't write this part, we can't write include C. Okay, so this is about the first remove unproductive symbol grammar. Okay, next I'll move to the next grammar, that is remove unreachable. Remove unreachable. Let's see what the grammar says. Removing unreachable non-terminals. Remove unreachable non-terminals is basically to check whether a particular non-terminal is unreachable or not. So let's see how to work on that. So first of all, let me continue with the earlier one. So that gives me the grammar. S gives AB, S gives AB, A gives A, B gives B. So if I continue with this, I will not get any answer, because finally after applying this, I will get the same grammar. That's why I will add some more into it. C gives C. So let me modify the grammar, whatever I've got from the previous one, so that I can explain these. Okay. Next, first of all, this will be your G dash equal to G. Okay. Next, mark S as reachable. First of all, mark S as reachable. What is S? S is the start symbol of your grammar. That's why identify and make that as reachable. Reachable is yes now. Yes. Next, what? Mark every other non-terminal symbol as unreachable. So that's why unreachable are A, B, C. Leave the start symbol. A, B and then C. Okay. Next, what you have to do? According to the fourth step, what you can tell is, if suppose X is reachable, if suppose X has been marked as reachable, then we can say that all the non-terminal symbols present here in the on the RHS are marked as reachable. If suppose this is reachable, then the non-terminal symbols that is present over here are also reachable. So now since S is reachable, what we can tell? A and B as reachable. So now it becomes reachable terms are from the first rule. Let's check the rule. S gives AB. S is reachable. We can say that all the non-terminals that are present on the RHS are also reachable. So S reachable terms non-terminals becomes S, A and B. Next, coming to A. A is reachable, but there is no non-terminal symbols over here. So let's move on to the next one. Next rule is B gives B. So what we can do is, so here also it's not going to give us any non-terminal symbols. So we can see the next rule. C gives C. So what is the meaning of C is not decided it is reachable, and there is no rule that is saying C is reachable. So that's why we can tell that C is unreachable. So we got in this, we have to remove this, we got unreachable as C. So here unreachable symbols are, yes, symbol is C. So if so, what you have to do? Remove C from the grammar. So this particular grammar need to be removed from the, this particular rule need to be removed from the grammar, because you can see here, remove from G dash every rule with an unreachable symbol on the LHS. Okay, so I can finally get removing that, the G dash as S gives A gives A, B gives B. So this will be your final grammar. So this is how you have to apply removing unproductive and removing unreachable non-terminals.